Good morning, students. How are you? Students, we are doing lesson 5, and the name of the lesson is Principles of Inheritance and Variation. And today we are in the last topic, that is chromosomal disorder. And after this topic, after this class, I will take one more class in this lesson to deal with the topic that we have missed, because there are certain topics which are added recently in NCRT last year. So we have missed some of the topics. So we'll learn about that topics in our next class. But today we'll finish this lesson. So the last topic that was left was the chromosomal disorder. In the previous class there was a net issue because proper speed was not coming, and therefore I have to end my lecture within 30 minutes. Okay, so students, that day, if you remember, I have given you the reason why the chromosomal disorder takes place. So there we have learned that chromosomal disorder takes place due to what? Due to absence, or due to excess, or due to abnormal arrangement of one or more chromosomes. Okay, now if these chromosomes are in excess, or if one chromosome is deleted, or one chromosome is added, or there is improper arrangement, then it leads to what? It leads to a type of disorder which is known as chromosomal disorder. And chromosomal disorders, there are many chromosomal disorders, but few are given in your NCRT, which are widely expressed, and which are widely distributed all around the world. So today we are going to discuss some of the common chromosomal disorders. Right? Now today the first one is the Down syndrome. This Down syndrome, it is basically a disorder which is caused due to a chromosomal disorder. Let us see which type of chromosomal disorder is present in the Down syndrome. Okay. Actually, student, the disease Down syndrome is actually present in a newborn baby. Suppose at the time of new cell formation, some extra chromosomes come. You all know that 2n, the total number of chromosomes in a diploid cell, in a human body, or in a somatic cell is what? 46. Okay, and if we arrange the 46 chromosome according to karyotype, then we have, since the chromosomes are paired, so we have 23 pair of chromosomes. Okay. Now, if you start counting 1, 2, 3, 4, 5, when you get a 21st pair, there what happens? If any small kid has Down syndrome, then there is addition of a single chromosome at 21st number of chromosomes. It means what will happen? What will happen? 2n plus 1. 2n. You all know that n is equal to what? N is equal to 23. Okay. So 2n is what? 2n is equal to 46 chromosomes. Okay. Now, in this type of disorder, one extra chromosomes is added at chromosome number is added at chromosome number 21. So what will be the genotype? The genotype will be what? If we can write in the terms of in the terms of the autosomal chromosome, or we can simply write here that suppose if you want to represent the Down syndrome, means how much number of chromosomes will be present if any child is suffering from Down syndrome, then it will be 2n plus 1. 2n is 46, 46 plus 1. Since one chromosome is added at which position? At 21st chromosome number. So 46 plus 1. So there will be the total number of chromosomes in a baby who is suffering from Down syndrome will be equal to 47. And if you see, it has deviated from the normal value of 46, right? Therefore, there are certain deformities which are formed inside the body. So if anyone sees that child on the basis of the symptoms which I have mentioned here, anybody can easily recognize that the particular child has Down syndrome. The other important thing about Down syndrome is that it's a autosomal disorder. Autosomal chromosomal disorder means there is the addition of a one wrong chromosome, not in the sex chromosome pair, but in the autosomes. Means you have what? You have total N is what 23. All this 22 are of autosomes, and a single is the sex chromosome pair. It means in this addition of one chromosome pair in this 22 pairs. So 22 pairs will be what normal pair, but the 21st pair will have an extra chromosome. So what 21 pair will be normal pair and one will be with extra chromosome. Okay, so therefore it becomes 2 and plus 1 and the addition will be at chromosome number 1. And it is the autosomal. Since the addition of chromosome is of which type? It is autosomal chromosome, which decides the general body characteristics. Therefore, this is the autosomal disorder. And since it is caused by a change in the chromosome number of autosomal chromosome, therefore, its symptoms are visible in the whole body. Okay, so let us see what are the symptoms which help us to recognize whether any such type, whether any such child is suffering from Down syndrome. Okay, so here are the symptoms of the particular disease. So the first is short stature. It means if the person is standing, okay, the length of the person will be small, okay, short. The person will be short. Then small rounded head. If you see, it is figure 5.16 in your NCR. Okay, so there are clear cut characteristic of a particular child who is suffering from Down syndrome is drawn there. Okay, so there you can see that the child is short, small rounded head with a small, the head is round. Okay, and the head is small also. Then furrowed tongue. Now these particular these particular children who are suffering from Down syndrome, they have furrowed tongue. Means a small furrow is at the near the tip region. Okay, that goes slightly back. So furrowed tongue they have. Next is partially open mouth. Every time if you see, most of the time these type of children they keep their mouth slightly open. Okay, and then the last one and the most important symptom of this particular Down syndrome is the mental, physical, psychomotor development is retarded. Means there is a mental retardation. Psychomotor means the ability to do the activities. Okay, the child who is suffering from the disease will not be able to perform any activity accurately. Okay, and the mental and physical development will be retarded, and mental development means the logical thinking. The child will not have, or he or she will have a very less logical thinking. So it means that the child is mentally retarded. And student, this type of syndrome can be detected when the child is in mother's womb. So you have learned one technique to take out the amniotic fluid from the mother's womb. So that fluid gives you the information to the doctor that the child is suffering from Down syndrome. So this type of syndrome is observed in a unborn child and a newborn child. Okay, and if any person, any child has this type of syndrome, the child cannot be cured properly up to the full extent. Okay, student. So what we have learned in Down syndrome, that Down syndrome is due to Down type of chromosomal disorder due to addition of the extra chromosome at chromosome number 21. Therefore, the chromosome of such child becomes 46 plus 1. So the chromosome number of that child becomes 46 plus 1, that is 47, and the child will show the following symptoms. Right, children? And this question is very important, that in Down syndrome, the addition of chromosome is at which chromosome number? So it is at chromosome number 21, and this addition is this addition is in the chromosomal chromosome, not the sex chromosome. Okay. Now we'll move to the next type of disease, which is Klinefelter syndrome. Okay. Now this Klinefelter syndrome, this is again a type of disorder which is a type of chromosomal disorder. Okay. And this particular disorder, it is different from this disorder because this disorder is caused due to a change in the sex chromosome. Okay, so it's a sex-linked chromosomal disorder. What is the difference between these two? One difference, there are many differences. One difference is because this is Down syndrome is an autosomal disorder. This is a sex chromosome disorder. Right, student? Now let us see what happens in Klinefelter syndrome for a person who is suffering from Klinefelter syndrome. Now again the diagram of Klinefelter syndrome you can see in your textbook. You can keep your textbooks open so there you can see the diagram. So it is figure number 5.17. Okay, diagrammatic representation of genetic disorders due to sex chromosome composition in human. The first one is Klinefelter and the second one is Turner syndrome. Okay, now just see the diagram. The Felter syndrome. There, the development of the whole body will be masculine. Okay, so why the development? The reason of masculine development of the whole body will we will try to find out in its chromosome number. Okay, so let us see what happens. What is the change in chromosome number? Students, you all know that the normal. Okay, students. Now what happens? Just here I am trying to explain you how it is 44 plus x square. Okay, so if we see a normal human being, there it is what? 44 plus what? If she is a female, then it will be XX, and if he is a male, then it will be 44 plus X1. Right? Okay? If any person is female, then it will be 44 plus X6. 44, 45, 46. This 22 pairs are what? The autosomal pair, and one pair is what? The sex chromosome pair. Similarly, in the male or the male human being, 22 pair of chromosomes means 44 chromosomes are autosomal chromosomes, and this X and Y, one X is for the one X. This one X is the sex chromosome, and if it is with Y chromosome, then the person will be a male, and that will follow. Now, student, what happens in Klinefelter syndrome? One extra X comes. Therefore, it is a sex chromosomal disorder. Okay, so here it means XXY. Therefore, we will add one X here. Okay, and we'll rub the former one. Okay, because if Y is here, it means the person will be what? Male. Okay, and here a single addition of sex chromosome, that too of X type, will occur, and it will become 44 plus XY plus X. It means 44 plus X and X and Y. So this will be the chromosome. These will be the type of chromosomes in a person who is suffering from Klinefelter syndrome. Right? Okay. Now, since you know that Y is there, therefore the overall development of the person will be masculine, and as a male human being grows, this particular person will also grow with good height. Okay. But what happens since there is extra X chromosome. And you all know that if double X are there, then it leads to a female characteristic. Because X chromosome forms the female characteristic, and that too they are present in pairs. Okay, so now two since two X chromosomes are present, therefore this male body will show certain characteristics of female's body also, like the feminine development of breast. Okay, the male will have a development of breast like the females, and this particular type of disorder is known as gynecomastia. Okay, so gynecomastia is what? It is the development of female's breast in the male body, in the masculine development, in a person who is suffering from Klinefelter syndrome. Okay, now because what the feminine breast development has taken place and additional X is present. Therefore, this type of particular males will be sterile. Okay, this is very important. This type of particular human being will not be able to reproduce. Okay, or to have children. Okay, students, so what we have learned in Klinefelter syndrome, we have learned that in Klinefelter syndrome is a type of disorder which is a sex chromosome disorder due to addition of one extra X. Okay, and since Y is there, therefore the person will have a masculine development of the body, but due to presence of additional X, the person will have a feminine development of breast, and this particular disorder is known as gynecomastia. Okay, and this person will be incapable of what? Incapable of reproduction, and the person will be sterile. Right? Now, let us move to the next type of syndrome, which is known as the Turner syndrome. Okay, so Turner syndrome is uh, again a type of disorder that takes place due to deletion. This was due to addition of one autosomal chromosome. This was due to an addition of a sex chromosome, and this is due to a deletion of one sex chromosome. And that is what? The X chromosome. Okay, so let us see how this happens. Okay, now students, for understanding this, again we have to move here. A normal human female has 22 autosomes and paired copy of X chromosome. If any person has this type of chromosomal arrangement, then the person will be a human female. That you know. These 22 are what? These 22 are the autosomes. And one pair of sex chromosomes. So the person will be a normal female. But since we are dealing Down syndrome means a deviation from the normal chromosome. Now what will happen? Since one X chromosome in this type of syndrome, there is a deletion of one X chromosome. Therefore, if we write the total number of chromosomes, it will be like 22 plus X. Only this type of what gamete will inherit only one X chromosome. Okay, and what will happen during fertilization? This type of this zygote, not gamete. During fertilization, this type of zygote will receive only one X chromosome and not two chromosomes. Okay, and here this is a normal female and this is the diseased female. So since there is absence of one X chromosome, therefore we write here 0 or absence of X chromosome. So here it is what? 22 plus XO, it means if it is 22 means a normal one. Okay. So if we make it 2 copy, okay, this we are doing the paired one means n. In n it is what? Okay. So what here will be? It will be 22 will be in a copy. Okay. So it will be 44. Okay. And the second one it will be X and what? Since the second one is absent or there is no X chromosome, therefore it will be 44 plus X4. Okay. And here also the normal will have what? 44 plus XX, that I forget to write, that is actually a paired one. Therefore, 44 will be the total number of chromosomes and XX will be the 23rd pair, that is X. Okay. So if I write it here in the similar manner, it will be 44 plus X4. Okay. Now when it is 44 plus X4, it means the two X chromosome when a zygote inherits two X chromosome, then only the female characteristics are described. Okay, but what happens if a zygote inherits only a single chromosome? It means that the female characteristics will be not fully formed in the particular type of female. So we'll see the symptoms of that particular disease. So here it will be what? 44 plus X4. It means 2y minus 1. There is deletion of one chromosome. Therefore, 2y is equal to what? 44. 44. Sorry, n is 23. So 23 into 2 it is what? 46. 46 minus 1. It means that the total chromosome number will be what? The total chromosome number will be 45. Okay, student. So here it is 45. Now, let us see what are the symptoms. The symptoms of this disease is that the females are sterile. Since only one chromosome is inherited in the zygote, therefore this type of female will be sterile. It means the female is incapable of what? Incapable of reproduction. Okay, and here also female are sterile and the ovary is rudimentary. Lack of ovary is rudimentary means ovary is formed inside the female, but a proper egg formation or ovum formation will not take place. Okay, so ovaries are there, but just for the sake of presence, but they will not perform the function. The next one is lack of secondary sexual character. Since only one single X is inherited, therefore, what is the sexual characters are also missing in these type of the females. So we can say that Turner syndromes normally occur in a female who inherits one less X chromosome in the zygote, and the zygote develops. Okay, but in Klinefelter's chromosome, one extra X chromosome comes in the zygote during what? During fertilization. Okay, students, here in the Klinefelter's also I have written 22. In place of 22, it will be 44. So let us write here. So a normal will be 44 plus what? If it is a male, then it will be 44 plus XY. I'm talking about Klinefelter syndrome. So if it is normal male, then it will be 44 plus XY. But since there is an addition of one X chromosome, therefore it will be 44 plus XY. Therefore it will be 44, 45, 46, 47. So therefore the total number of chromosomes in that particular type of person will be 20. Will be what? Will be 47. And here what will be the chromosome number? 2 into 23, 46 plus 1. So here also the number of chromosomes will be 47. Okay. So in giant round syndromes also the total number of chromosomes is 47. In Klinefelter also it is 47. But the difference is here there is the addition of a autosomal chromosome, but here it is addition of what? Addition of a X chromosome. Okay. And this particular type of syndrome is normally seen in a child, even in the newborn child. Okay, and in the unborn child also. and this type of um, syndrome is present in a child also, but when the child grows, they are easily visible. Okay, so these are the types of syndrome that we have learned today. And students, just if you have any doubt, please post it so that I can have a look to the difficulties that you had in this lecture. And students, whatever we are left with means polygenic inheritance, and we are left with sex determination in honeybees that we'll study in the next class. Before ending up the lecture, if you are not asking any doubt, let me show you how this there is a non-disjunction or addition or deletion of the chromosome by a simple diagram. Okay, students. Just I have drawn this diagram to show how it happens. Okay, I think this is visible. Mm, yes. Now you can see here. Suppose these are the two cells that I have drawn. Okay. Now what happens? Suppose these are the cells which will form gametes. Okay. From this cell we will form the female gamete. That is the ovum, and from here will form the male gamete, which is the sperm. Now what happens? How the chromosomes are added and how the chromosomes are deleted, which leads to these types of syndrome. Will understand by these diagrams. Okay. Now, what happens if you have learned karyotype? All the chromosomes when they are paired, this is the diploid number. Okay, so it's a cell with diploid number of chromosomes. So it is also not female and this is also female. Right? Okay. Now, what happens during you all know that before the cell division, when the cell division, all the chromosomes they come and lie at the center. Okay, so suppose these all chromosomes what I have drawn here, they are arranged in the center of the cell. Okay, so here since all of the 22 pairs are they are arranged in the pairing manner. These 1, 2, 3, 4, 5, 6. In this way we have arranged all the 22 chromosomes at the center. Similarly, here also the 22 chromosomes are arranged in a paired manner since they are homologous chromosome and they are paired. In this 22 are the autosomes. Now what about sex chromosome here? Now suppose here the last one is the X, okay, and here the last one is X. Now you understood. This 22 are the autosomes, and here this is the X, and this is again X. This is because this is the diploid cell from the female's body, which will form what? Which will form a ovum. Okay. So now what happens? Suppose during means after the cell division, after the pairing of chromosomes, there is exchange of genetic matter, and what happens? Now the chromosomes have to go to their opposite poles. Two copies are made. They are arranged in the center, and now the chromatids have to separate, and they will move to the separate poles. Now during movement to the separate poles during telophase, what happens? Suppose this particular chromosome comes in this type of lineage. Okay, here 22 were going on that pole, but along with 22, one X was initially going, but along with that there is non-disjunction of the chromosome. Okay, and this was linked with this, and this has gone along with this. Therefore, here it will be what? 22 plus x. Right? Okay. And now since 1x has gone on that side during the separation, okay, therefore it will become 22 plus what? It will become 22 plus 0. Nothing. You understand? Understood? Means half of the gamete will have this type of condition 22 plus double XX. Okay, and half of the gamete will have 22 plus 4. Okay. Now let us see in the males. Okay, suppose there is a normal cell division and both of them have segregated this way. Okay, so here 22 plus x has gone that side and y has gone that side. Or you can just understand here that here it was x and here it was y. So when the separation took place, the x has gone here and the y has gone here. Okay, so what will happen? What will happen? It will become 22 plus x and it will become 22 plus y because this is the diploid cell in a male. Therefore, one x and one y. This was the diploid cell in female. Therefore, one x was there and one x was here. But they haven't separated and two x have gone on that side and there is no x. Now, what happens when this type of ovum will fertilize this one? Okay, when this type of ovum will 22, what it will become? 44. Okay, x plus 1. So x, y. So if this type of ovum fertilizes with this type, then it will result into Klinefelter syndrome. Okay, and if suppose this one means 22 without any X chromosome will fertilize with a sperm having 22 plus 1 X chromosome, which is a normal sperm, then what will be the chromosome number? It will be 22, 44 plus what? Plus 0 and X. Okay? X. So 44 plus x squared. So therefore, if the fusion is like this, then it will lead to what? Turner syndrome. Therefore, we have seen that in this type of cell division, we have seen that there is an absence here. It was absence of X chromosome. Okay. Then there is excess. Here it is excess of chromosome. Okay. Then abnormal arrangement. This type of arrangement. Here it is abnormal arrangement because one chromosome was added where in the 21st chromosome. So here we have seen certain chromosomal disorders. I hope you have enjoyed the lecture today. Anshuman, thank you, and we'll join in the next lecture to finish the topics which are remaining. One student, just a minute, I have a doubt. Whether you had a doubt. If it is 44 plus x, y, then it will be Klinefelter. No, it is not a Klinefelter syndrome. If it is 44 plus x, y, then this particular type of individual will not exist, and this is not Klinefelter syndrome. Klinefelter syndrome is only 44 plus x. Okay, children. So, enjoy your day.